All right. Let's talk about the implication of these inclines on friction. So we've talked about two different types of friction, but since they have the same basic calculation, we're just going to look at how it affects kinetic friction. If I was sliding something along a flat surface, let's say I took a book and I slid it along one of these desks. And I gave it some velocity. So it experienced some kinetic friction. That has a value of mu. Now, if I put this thing on an incline, same book, on the incline, first of all, is the coefficient the same in these two situations? If the surfaces are the same, they're the same. So even though that I've inclined it, maybe it's not even moving anymore, maybe it's moving faster, it doesn't change the surfaces themselves. So the coefficient of friction between these two is going to be the exact same. Coefficient depends on surfaces, not on anything else. Which one of these things, let's say they're both moving at constant. Yep. Suppose that they're both moving at a constant velocity. Just the friction, focused on just the friction, who is experiencing more kinetic friction? Why? Okay. So let's look at what Matthew said here. He says that the friction on the flat surface is going to be greater. So kinetic friction on flat is greater than the kinetic friction on incline. Yeah, you can write that. That's correct. So his reasoning was because the normal force on this surface is greater than the normal force on this surface. And is that accurate? Well, kinetic friction depends directly on the normal force and the coefficient. We've already established that the coefficients are the same. So the kinetic friction here is directly proportional to the normal force. So if the normal force goes up, the kinetic friction goes up. The normal force goes down, the kinetic friction goes down. So what is the normal force on this flat surface? Right, the normal force on the flat surface is equal to mg. The forces up have to equal the forces down in order for it to be in balance, to be in equilibrium, where it's not accelerating. What is the normal force on the incline? N is less than mg. Specifically, normal force is equal to what? Mg cosine theta. Right, specifically mg cosine theta. So in the inclined plane, normal force is equal to mg cos theta. So if I put any number in there for theta, what happens to the normal force? It goes down, because cosine is restricted between 0 and 1. So it's got to be a fraction. This number has to be a fraction, so this number is always going to be smaller on an incline than it is on a flat surface. So the kinetic friction on an incline is going to be different, less on the inclined plane. Where's the what? Any questions about that logic? Everybody good with that logic? Okay. Following that?